All right, so on to the next example. With number 4, we have the tangent of x plus the cotangent of x equal to the secant of x times the cosecant of x. So in this particular case, I don't think one side of the expression, or sorry, one side of the equation looks any more complicated than the other side. But if I have a choice as far as like manipulating something where I'm adding or subtracting in comparison to something that I'm multiplying or dividing, I think it's easier to manipulate the side that we are adding or subtracting. So that means I'm going to start with the left-hand side in this instance. Okay, so when I start with the left-hand side, when I look at the right-hand side where I'm trying to go with this, secant times cosecant. Secant is 1 over cosine. Cosecant is 1 over sine. So I can take the right-hand side and write it as 1 over cosine times sine. So again, that's in terms of a single fraction. So that's probably going to tell me like what I need to do with the left-hand side. And because the right-hand side I can write in terms of sine and cosine, I'm going to go ahead and take the two expressions on the left-hand side and write them in terms of sine and cosine. So tangent is sine over cosine. Cotangent is cosine over sine. And again, on the right-hand side where I'm trying to go with this, that's in terms of a single fraction. So I'm going to combine these two fractions into a single fraction by getting a common denominator, which is cosine times sine. For me to give the first fraction that denominator, I need to multiply the numerator and denominator by sine. So that's going to make that first numerator sine squared. For me to give the second fraction that common denominator, I'm going to multiply the numerator and denominator by cosine, which is going to make that numerator become cosine squared. And we know using the first Pythagorean identity, sine squared plus cosine squared is 1. So that's 1 over cosine times sine, which I can then break that fraction up into two fractions, the product of two fractions. So that's 1 over cosine times 1 over sine, which 1 over cosine is the secant of x, and 1 over sine is the cosecant of x. Okay, so we verified that identity. With 5, doesn't matter what side we start with here. Again, I don't think one expression is more complicated than the other. I'll actually work this out. I'll verify this identity both ways. So if I start with the left-hand side for 5, we have the secant of x plus the tangent of x, which when we look at the right-hand side, that's written in terms of cosine and sine. So I'm going to go ahead and write secant and tangent in terms of cosine and sine. So secant is 1 over cosine. Tangent is sine over cosine. And then for me to transform that into the right-hand side, like I look at that right-hand side, and that right-hand side is written in terms of a single fraction. So I'm going to go ahead and combine the left-hand side in a single fraction. So we have a common denominator of cosine, so this becomes 1 plus sine over cosine. Now, when I look at the right-hand side where I'm trying to go with this, when I look at that denominator is written in terms of sine. Well, the only way that I'm going to be able to write cosine in terms of sine is if I get that denominator to become cosine squared, because we know cosine squared using the top Pythagorean identity is 1 minus sine squared. Okay, so that kind of tells me what my next step needs to be. So if I multiply the top and bottom by cosine, we get the cosine of x times 1 plus the sine of x over cosine squared, which we can rewrite that denominator using the Pythagorean identity as 1 minus sine squared of x, which that's the difference of two squares. I can factor that to 1 minus sine times 1 plus sine and then we can cancel those factors of 1 plus sine. So that gives us cosine over 1 minus sine, which is what we were trying to show. We can also take the right-hand side and manipulate it using algebra and identities to show that it gives us the left-hand side. We would just like work through this process in the reverse order of steps. Okay, so what I could do here is multiply the top and bottom by 1 plus sine, which that's a new technique. Like we haven't done that for an identity yet. I can then multiply across, so we get cosine times 1 plus sine over, when I multiply those two factors on bottom, that gives us 1 minus sine squared, which 1 minus sine squared, we can rewrite that as cosine squared. Then I can cancel the factor of cosine on top with a factor of cosine on bottom. So this becomes 1 plus sine over cosine, which I can take that and split it into two fractions by taking each term in the numerator and writing it over that denominator. So 1 over cosine plus sine over cosine. Well, when I rewrite each of those fractions, 1 over cosine is secant, and sine over cosine is tangent. So it doesn't matter which way you choose to verify the identity. This one you can work through in both directions. And I think, like, as far as the work that you have to show, it's similar for each one. Okay. Last example that we're going to do is cotangent squared over 1 plus cosecant is going to be equal to 1 minus sine over sine. So I think the left-hand side is the better choice to start with here. And I think it's the better choice because the numerator is cotangent squared. And I can, using the third Pythagorean identity, I can get that written in terms of cosecant. Okay, so cotangent squared is going to become cosecant squared minus 1 over 1 plus the cosecant of theta. And then that numerator is the difference of two squares, so I can go ahead and factor that. That's going to factor to cosecant of theta plus 1 times the cosecant of theta minus 1 over 1 plus the cosecant of theta. And then I can cancel cosecant plus 1 with 1 plus cosecant. Again, doesn't matter which order we add in, those two sums are going to be the same. Which leaves us with cosecant of theta minus 1. Well, when we look at the right-hand side is written in terms of sine only. So we're going to rewrite cosecant in terms of sine. So cosecant is 1 over sine minus 1. And then I just want to get a common denominator so I can combine that into a single fraction. So my common denominator for both of those fractions is going to be sine. That first fraction already has that denominator, so I leave the numerator alone. To give 1 a denominator of sine, I have to multiply the top and bottom by sine. So I can rewrite 1 as sine over sine. And that gives me the right-hand side of this equation, 1 minus the sine of theta over the sine of theta. Okay, so that wraps up trigonometric identities. We'll take a look at solving trig equations in the next lesson.